Hello, welcome to my channel. In this video I'm gonna solve a problem. So the problem is on vector calculus, and I am using the book Elements of Electromagnetics by Mathew Sadiku, and the chapter is 3, and we are solving the practice exercise 3.1. So here's a figure of an object which is described by r in this range, theta in from 60 to 90 degree, and phi from 45 to 60 degrees, where surface r equals 3 is the same as AEHD. AEHD, this is the surface r equals 3, and surface theta 60 is AFB, surface theta 60. So AEFB. AEFB, this is the surface theta, and surface phi equals 45 is ABCD. So surface phi is ABCD. We have to calculate the length of DH, FG, calculate the area AEHD, the area ABDC, and the volume of the object. So let's get started. So before we start solving the questions, let us first understand what differential length, differential surface, and volume means. So differential length. So differential length dl equals dx ax plus dy ay plus dz in the direction of az. This is in Cartesian. D rho in the direction arrow plus rho d phi in the direction phi plus dz in the direction az. This is in cylindrical, and in spherical dr in the direction ar plus r d theta in the direction a theta plus r sine theta d phi in the direction a phi. Let us define differential surface, which is ds. So let me write this S, the capital S. So ds is in general is defined by ds with vector, unit vector. This the an means unit normal vector. So the surface in the direction of ax is dy dz in the direction ax. The surface xy in the direction in the direction z is dx dy in the direction az, dx dz in the direction ay. So in the direction a rho, the differential surface will be rho d phi dz in the direction a rho. The differential surface in the direction a phi is d rho d theta, d rho dz in the direction a phi. The differential surface in the direction az is rho d rho d phi in the direction az. So say that we want to know the differential surface in spherical, where the differential surface in the direction AR, which is r squared sine theta d theta d phi. Sine theta d theta d phi in the direction AR. Say we want to find the differential surface in the direction A theta, which is r sine theta dr d phi. R sine theta dr d phi d phi a theta in the direction a theta. Now we want to find the differential surface in the direction a phi, which is r dr d theta a phi. So these are the differential surfaces in the corresponding orthogonal systems. Now for differential volume, differential volume dv, say this is capital V, which is, so volume doesn't have any direction, so in Cartesian it is dx dy dz. In spherical it is rho d rho d phi dz. And in the spherical coordinate systems the volume is r squared sine theta dr d theta d phi. So this is the representation, these are the representations of differential volume in their corresponding coordinate system. Coming back to the question, so we have to find the arc length. So first question is the arc length. The arc length dh. We have to find the length of dh in this term. So we have known that the surface r equals 3, so which is this. So this is the surface r equals 3. So if you don't understand what surfaces are, you can watch my previous practice problems on EMF. I have discussed about in my previous video, so you can watch it there. So I'm not discussing this here. So this is basically the surface, this whole surface. A E D H. So we have to find the length dh So to find the arc length dh, consider a point from D which is traveling from D to H in the spherical coordinate system, obviously. So the differential length here would be differential length for this arc is R D. So this is R sine theta d phi. All the other coordinates are constant. Only the the point is moving. Um, the point is only moving along the phi axis. So here let us define a point from D which is traveling to H. So in this spherical coordinate, this is obvious, this figure is obviously in spherical coordinate, and the range is R is from 3 to 5. So here R is 3, and say at D is R is 3, and at C R 5, and theta is 60 to 90. So theta is from 60 to 90, it's traveling, is rotating. Phi is traveling from 45 degree to 60 degree. So these are the ranges. So here in this case only phi is being changed from 45 to 60, and the other variables are constant. Theta is constant and R is also constant, but phi is changing. So the other component of the differential length are 0. They are not changing, only this part remains. So we are gonna just find the value for this. So here R is 3. So because this is happening in the surface R3, 3 cross sine theta. So here theta is 90 degree. So theta is from here, theta, say by reference, theta here is 60, and after traveling from A to D, the rotating, after rotating it becomes 90. So theta is 90. This is rotating like this, and we are gonna integrate from phi equals 45 to phi equals 60. So the arc is moving from like this. So from 45 degree angle to 60 degree angle, which is d phi. So if we calculate this, so 3 cross 1 cross, so this is phi phi. Let us define this by in radians. So pi by 4, pi by 3, which is 3 cross pi by 3 minus pi by 4, which will give us the answer 0.78539. So this is the answer. So now we have to find the arc length FG. So FG is here. This is FG. So in the spherical system, this arc is obviously part of the surface r equals to 5 of the bigger surface FGCB. So this is r equals to 5. Obviously you can see that. So we have to find the length FG. So what is happening, say a point is traveling from F to G like this. So here r is constant, phi is constant, but theta is changing. So theta is changing from 60 to theta 90. So here differential length is r d theta. So we have to find this. So r is 5 cross theta equals 60. So here theta is 60, and here from F to G, so theta equals 90. We have assumed this like this, that the point is moving from theta 60 to theta 90. So this will give us 5 cross. So if we write this in radians, so pi by 2 minus pi by 3, this will give us so this is the answer. So now on to the next question. So question C, we have to find area of surface AEHD. So the surface AEHD is this little surface. So AEHD, this is obviously the surface r equals 3. So we have to find the area. So the differential surface is in the direction AR, is differential surface is r square sine theta d theta d phi. So in the direction AR, so we have to find only the magnitude. So we needn't write the air part. Observe that r is constant, theta and phi are changing. So r is 3 square and sine theta d theta, which is this, and d phi. Theta is changing from 60 to 90. phi is changing from 45 to phi equals 60 degree. So if we just integrate, so 9 cross minus cos theta, so in radian pi by 3 pi by 2 cross phi pi by 4 pi by 3, which will give us the answer. So 1.178. This is the answer. This is the area for the answer for the area AEHD. So now we have to find the area ABDC. Now in the question D, we have to find the area of the surface ABDC. So the surface is, so this is the surface ABCD. So in the direction phi equals 45. So this is basically the surface. This is basically the surface phi equals 45. So we have to find the area. So differential surface is um, for in the direction phi is r d r d theta in the direction phi. So s is here r is changing, so from r equals to 3 to r equals to 5, r d r, and theta is changing and phi is constant, which is 45. So theta is changing from 60, theta is 60 to theta 90 d theta. So we have to do r2. The answer is 4.18. So this is the answer. And now for the last question of this exercise is find the volume of the object. So we know differential volume is d sorry r square sine theta dr d theta d phi. No direction, it spreads in all direction. Volume spreads in all direction, there's no particular direction. So v is integration r equals 3 to r equals 5, from 3 to 5 r squared dr sine theta d theta. Theta is 60 to 90, 60 to theta is 290, integration phi equals 45 to phi equals 60. So d phi. So if we just integrate these, So if we just plug the values, 49 by 36 pi, or 4.276. So this is the answer, and that's it for this video.